Hello everyone and welcome to this video on differential equations. Specifically, we're going to generate a slope field from this problem and then we're going to solve this bad boy. Okay. So anytime you're doing a slope field type thing, you really want to think, are there any zero slopes, right? Are there any points where the slope is zero? So here's dy dx. dy dx, of course, is our slope. And according to this problem, it's equal to 4x divided by y. If we set that equal to 0, then we wind up with 4x equals 0, or x equals 0 if we divide by 4. So, x-axis, right? Here's x equals 0. This is saying no matter what, when x is 0, the slope is 0. So, as we go up here, no matter what y is, x is 0 on the y-axis. And the slope, as we can see here, the slope is 0 there. And so we're going to have 0 slopes everywhere. And I know it looks like I'm just making marks on the y-axis, and that's not what I'm doing. I'm drawing the slope. The slope is 0 everywhere that x is 0. So that's the y-axis. Okay, awesome. Now, it says here that y has to be bigger than or equal to 1. Okay, so we can't have anything down here. So let's keep that in mind. Y has to be 1 or bigger. So now let's think about what happens as we increase x. Okay, so we're going to keep y the same. We're going to increase x. And so, think about x equal 1. Okay, here, let's do this. Let me change my color. We're going to consider y equals 1, and we're going to increase x. Okay, so if x equals 1, then we get dy dx equals, or I'm going to abbreviate, we would get y prime equals 4. If x equals 2, then we're going to get y prime equals 4 times 2, which is 8. Okay, so basically the slope is going to increase by 4 every single time x goes over to the right by 1. So basically we're going to have a steep slope here, and we're going to have an even steeper slope here. Okay, it's just going to get steeper, steeper, steeper as we go. Okay, now on the other hand, if I increase y now, if y gets bigger, let's say y equals 2, then let's think about x equal 1. We'll have 4 times 1 divided by 2. 4 divided by 2 is 2. So this slope is going to be half as steep as this one. Okay. Now let's consider 2, right? Let's consider x equal 2, y equals 2. So if that happens, we get 2 over 2 here. We get 4 times 2 over 2, which is just 4. So in other words, this slope is going to be identical to this one. So whatever you drew this one as, just try and make this one exactly the same. Okay, very cool. All right. Now let's try what happens if y equals 1 and x is negative 1, right? Y equals 1, we get 1 down here. 4 times negative 1 is negative 4. So negative 4, that's going to be the same steepness but opposite direction. So instead of going up to the right, we're going to be going down to the right, kind of like that. Except, let me actually line it up here. About like that. Okay, same steepness, just opposite direction. Okay, now if x equals negative 2 and y equals 1, we're talking about, negative 8. So same steepness as this one, but negative. It's almost vertical. I mean, negative 8 is like really steep. It means you're going down 8 every single time you go over 1. So there we go. And from there, let's see, how about this one, right? Negative 1, 2. 4 times negative 1, negative 4. Negative 4 divided by 2, negative 2, right? So once again, same steepness as the one on the right, just opposite direction here. So a little flatter. Yeah, kind of like that. Okay. And likewise, this one is going to be the same as this one. Okay, awesome. All right. And now, we can kind of understand what's going on. So as y increases, think about x staying the same and y getting bigger. If y gets bigger, y is in the denominator, okay? So that's going to make the slopes a little flatter, right? So as we go up here, the slopes are going to get not steeper, they're going to get flatter, okay? And it's never going to quite be zero. It's hard to draw the relative steepness sometimes. But basically, as we go up, they're going to get flatter because y is increasing and x is staying the same. That last one wasn't very good. Yeah, something kind of like that. But on the other hand, as we go to the right, as x increases, the slope's going to get steeper. And it's going to get 4 times steeper than the rate of flattening that y causes. Okay, so if I come over here, this is going to be really, really steep. This, again, if we're going up, I'm sorry. Let's look at this one, right? If we go up from this one, it's going to be a tiny bit flatter. There we go. But if I go over more, it's going to be really, really steep. Okay, it's going to get really steep really fast. Okay. Yeah, we're increasing x. This kind of thing. Okay. And then we're always going to be mirrored on the other side for this particular problem. Okay, and so we get the basic idea. When they ask you to do slope fields, fill in slope fields, they usually only give you 9 or 12 points. So we've already done more than they would usually expect you to do. But that's just it. You plug in points. And then you plot the slope, okay? So if the slope is 0, it's flat. If the slope is 1, it's 45 degrees. If it's -1, it's negative 45 degrees, so on and so forth. And then using this, we can sketch solutions, right? So that's the idea, and that's why these are useful, is, it's like if you can't find the solution, straight away, then you can do a slope field. And then when you sketch the slope field, you're sketching the solution, kind of like this. Kind of like this. It's all about finding the best path that's given to you with the slopes, and then you can sketch the solution. Okay, so that's another thing we can do with the slope fields. So both of these are common things, okay? It's common to have to fill out slope fields, and it's also common that they'll give you the slope field, and you just have to sketch the solution, sketch the curve. So not too bad, I hope. Let's go ahead and solve this bad boy. Good old separation of variables, okay? So we want to get the y's on one side, the x's on the other. So I'm gonna multiply both sides by y, and then I'm gonna multiply both sides by dx. So I get y dy equals 4x dx, and then there we go. Variables are separated. Let's integrate both sides, right? So here we're gonna have y squared over 2. This is the independent variable side, so we're gonna have 2x squared plus c. Okay, And we do have this condition that y at 0 equals 1. Okay, so yeah, let's go ahead and apply that. So if y is 1, 1 squared is 1, 1 divided by 2 is 1/2. And then we get 2 times 0 squared plus c. So, right, c equals 1/2. Okay, so boom, there we go. So we have y squared over 2 equals 2x squared plus 1/2. And by the way, this is called an implicit form solution. Okay, this is the implicit form. It's implicit because we don't have y solved for directly. We don't have y equals something. We have y squared over 2 equals something. And the advice that I want to give everybody is, if you can find the explicit, then do it. Okay? But if it's really, really hard to find the explicit, then don't do it. Okay? So in other words, here, all I got to do is first multiply both sides by 2, like that. And then if I do the distribution, I'll get 4x squared and then plus 1. Okay, so I have y squared equals 4x squared plus 1. Y equals plus or minus the square root of 4x squared plus 1. Okay, and now, do we want the plus version or the minus version, right? Well, we know that y at 0 has to be 1, so we can double check. Okay, so I'm going to put 1 in, and I'm going to get plus or minus the square root of 4 times 0 squared plus 1, plus or minus the square root of 1 equals 1. Ooh, okay, well, that's only going to work if we have the positive case, so we're going to reject the negative. Okay, because 1 is not the negative square root of 1, it's the positive square root of 1. Okay, so our final particular solution is going to be the positive square root of 4x squared plus 1. And once again, this is called the explicit solution. All right, very nice. So there's that. And that's all I wanted to cover in this video. So I will see you in the next one.